I understand you don't have a question on lecture 3. If you have any question, you can ask later also. When you remember, you can ask. There is nothing like that. Okay, no problem. Okay, this lecture focus on the POTW, that is the wastewater treatment plants, and industry and waste management, right? So we are going to study what are the components. I have mentioned the what are the various component of this wastewater, industrial wastewater management towards sustainable and safe environment, right? And the system should be create in a safe environment, and at the same time it should be a sustainable, right? What you design, any treatment unit or the treatment system must be sustainable. What are the various components of this? Components of all permit means that is the authorization given by the regulation, right? You give an authorization for industry. Right? Here also there are many regulator bodies issue the permits, right? Licenses, right? Authorization to discharge. That is the word which is synonymous with the permits, right? The components of specific non-POTW, effluent guidance, case-by-case limitation. I have mentioned about this. You have in a system where the guidelines are given to you, how to do. And there are certain situations, a new industry is coming into the town, and some of the discharge pollutants, contaminants are not traced in the beginning. Then you have the authority initially by your best management practices, judgment, you can assign certain parameters to be monitored. Then once you know, within a period of 6 months or a year, you will understand there are certain things which are causing an interference or pass through. You can also modify the authorization and put more limits. So that is what case by case limitations, right? And what are the various components? Effluent limitation, technology based, water quality based. There are certain technologies are implemented for taking care of the wastewater. In certain cases, you are not sure about the technology because there are certain pollutants you are not well developed. There are certain cases with me where I have dealt with. You don't know have available technology to treat it to that level. Now you are aware of treating what is the BOD, what is the TSS, what is the ammonia, nitrate, is it? These are the common, some of the parameters you know. If I say there are certain components which are in terms of 0.00 milligram per liter, many of the environmental background people might can understand. So how we will measure? Right? We use a different equipments, gas chromatography, HPCLC. There are certain things. You want to study some what kind of a bacteria exists. You want to know, is it different type of bacterial growth which are used in the biological system. You want to know whether you are really treating or it is ending up in the sludge. That is why we do a sludge analysis. The first question, there is the treatment is not kind of an unknown box, right? You must know what is happening in the system, whether they are really treatment is going on. Where it is going? Converted into, is organic compound is converted into carbon dioxide and water, right? Then in certain components, where it is going? Converting into what? You must know the chain reaction, what is going on, right? So that is how you need some technology based, and for unknown things, some the water quality based. You know certain industries produce this kind of a wastewater. You can put directly, you can put a BOD monitoring, you can put a suspended solids. If it is some kind of a food producing industry, you can also put nitrates, right? So that is what is said, technology based and water quality based monitoring and reporting, special conditions, additional monitoring and special studies. Sometimes you want to conduct a special studies to understand more about the wastewater discharge, right? You cannot just say the industries, oh, we don't have any regulation for that, but you have tools. You can say it is a new one, so we want to put these are the parameters based on how we will do that decision. As a scientist, as an engineer, as an expert, you will see what are the raw materials used, what is the product. These raw materials, when they are used in the production, probably these may be coming into the effluent also. So you will see, you may be wrong, then you will get a no detection for many months. Then you will say you will modify. This is not required. That has happened in many cases. There was a situation, oh, another 5 minutes. There was a situation with me there. This was a big coal mine industry. People in the regulations, they monitored BOD, COD, nitrate, other things for many years, right? If you don't pay attention, suddenly they came to know that the selenium is also one of the contaminants. Because what happens in the coal industry, you take the good stuff in that and the rocks will be stacked. Then when the rain occurs, all the selenium started entering the water system. You will, at one slide, I will show you what are the effects of these contaminants. Is it? So they were not knowing. Many years you just kept on measuring the some of the substance where BOD is 150, 150, 200, and suddenly you came to know this is existing. Oh no, this is about 10 milligram per liter, it is harmful. We want to put a regulation. But do you have a technology to take care of that? You cannot just tell the industries that you put a 10 milligram, there is no technology available at that. That is why it occurs on this side also. That is why the constant evaluation, understanding of the wastewater, what is coming into the system, right? Otherwise, you wasted lot of time here. Then they said you cannot put the limit immediately because you want to first understand how much quantity it is available, whether it is in 40, 50 or 100, 200 or it is 10. If you don't know, how we will come to that number? When you put a number, you have to be serious. Like, you can say things are good. If I ask you what percentage, then you start thinking how much I should say. That is how it is. So these things occurs, special condition, additional monitoring, special studies. Then they say they put a group of smart people to study this, understand. They put a lot of resources into that. In a period of 2 years, they will collect the data. Then they will come to an understanding. Oh, this is the range in different kind of coal mines. Then we can put this much is the limitations, right? So the special studies are done. Component specific to the POTW, secondary or equivalent to secondary pre-treatment, municipal sewage sludge, CSO, and all these things you will study in the biological treatment. Sludge is also an important factor to be taken care of that. Once the wastewater treatment plant always produces a sludge, you must know what it consists of, right? where you want to dispose, what are the contaminant in that. So that is how the uh, municipal sewage sludge management is also a very important component in the system, right? Okay. Now we'll give a break. Enjoy your tea and coffee, relax. Then we will continue. Okay. Thank you. Can you hear me now? Okay, good. I hope you enjoyed the break, relaxed. We are talking about the industry treatment plant and the waste management. How there is a link between the discharger and the treatment plant. How that is managed. That is important component in the wastewater treatment system, because there should be a proper understanding between the two stakeholders. There are many stakeholders as you move forward. Of course, the regulation is also one part there, one component, important component. Observe both the things. The treatment plant may be delegated or it may not be delegated, right? If it is not delegated, that you should understand that it is managed directly by the government authorities, controlling authority. Sometimes government want to give some liberty. Oh, these guys are good, they can handle. So that's why we authorize them to run the program and we will oversee. That is how I do for many cities. In many industries, I oversee directly, and some cities I authorize and I oversee how they are doing. And a continuous understanding about their engineering, the way of dealing the issues, how they are imposing, they are continuously monitored, right? And also the technical guidance. Education is also a very important component in that, because when new coordinators come into the city system, you need some guidance to them, right? That is what you guys will do. When you grow many years of experience, you will train your youngers, right? So that is how there is an understanding also. That interaction is very important component in the treatment system. And what happens, what is the another component? Then some engineers, consultants will also involve. Many people, many industry cities, they in small cities, they don't afford to hire an engineer. I have not seen many municipalities have engineers here, right? Big municipalities, right? We talk more about the council, corporate elections and all, but the people who are working on the ground and taking care of, nobody knows, right? So these are the different components in the treatment system. Then there should be a proper management in order to make it successful. So I spent some time in making you understand how you deal with the different components of this management. You have seen the different system, guidelines, technology based, water qualities, monitoring reports, special conditions. If you don't know on either side, I gave you an example. There were situations when, okay, regulator means what? If you are on the regulator side, you can just put any limits. No, you may be on other side also, right? So those are the things that what you will have to do. You continuously upgrade, understand, and you may be having your education and experience. And third one is will to contribute and create. That is important, right? So for that you need any extra step. You are doing that just for yourself. I will share some of my situations whenever possible. When we are free, we can talk about that. You can ask any questions. In the tutorial also, I have put some of the case studies where I will explain this was the situation, how it has been dealt, how we work together, industry, regulation, and the treatment plants and other stakeholders, how we coordinated and made it successful. Similarly, you can also share if your experience little bit. This was the issue. How we will share that? This was the issue. So these were the situation. We dealt this way. These are the tools we used, and this is the result. How you do the project management. There are some management people also. They can put together that very well. So that way you can also share. That way we will understand how the system works. You have seen in some cases people who are there, critical situations, how they are dealt, right? So this particular, the various components of this industry and the discharger and the receiving POTW manage. And I was talking about the sludge also, right? Sludge which is produced in the secondary containment and primary, how they are taken care of. Biosolids, NPDS permits, in the sense permits authorization who discharge the wastewater to the rivers, right? They are covered under. So biosolids use and disposal under this, right? That gives the guidelines how the biosolids are converted. Many treatment plants, they have a big business of converting these biosolids into a manure, right? They sell it, they make a good business. Here also it is speeding up. In many places it is happening. But what is important, when you sell that biosolids as a manure, it pollutants, right? So if there is a pollutant, how that pollutant comes into sludge? The discharger, or if the treatment plant was not capable of treating, what happens? It will end up in the biosolids. So your whole thing is, the plan is spoiled. You cannot sell that. You cannot apply the solid or sludge or the manure which is created from the wastewater treatment plant to an agriculture, applying it to the land. So that is why it is very important. All the time I was emphasized on the interference and pass through. If it is causing a disturbance, there is an issue. If it is passing through, if you are not measuring, if you are not taking care of the pollutant, it will just pass through and end up somewhere, right? Which will cause a big issue. So that is what the biosolid use and disposal is also an important factor in the treatment. So what are the objectives? Prevents the introduction of pollutants into POTW, that is the wastewater treatment plant, which will interfere with the operation of the treatment plant, including the use or disposal of biosolids. Prevents the introduction of pollutants into the POTW, which will pass through the treatment works or be incomplete with the operation, right? So improve opportunities to recycle, reclaim municipal and industrial wastewater and biosolids. Many industries are, the cities are doing. They are treating their wastewater and applying it to the land for growing crops, and also applying it to the land to recharge the groundwater, right? So yesterday you saw an example there. They were using the wastewater, treated wastewater, effluent, to grow certain plants there. He was putting a small one. Today you will see a large scale in the tutorial. It is already done. Many wastewater treatment plants, they treat the wastewater and it is applied to the land. I will give you example. Many like that. That is the trend in many places, right? Big, your computer industries, like, they use a lot of water for air conditioning. that water is treated, recycled, and they use it for various purposes. That water is recycled, then discharged. So those are some of the things. What are the different components here? Industry, discharge wastewater to the wastewater treatment plant. If it is passed through, it will come out here. Hazardous, it may create a problem if you are not taken care of. It will also cause the sewer systems will be spoiled because of corrosion. If a low pH wastewater is discharged, then it may cause an interference. And there is a limitation. Sludge which is coming out of the treatment plant is the sludge and biosolids. If it has a contaminants, that very sole purpose of the objective is destructed, right? There are some numbers. The production and utilization. Nationally, 7 million dry ton per year. Regionally, 100,000 ton. And state, rural state, and urbanized state. And one way estimated your dry treated biosolids production 0.35 to 0.5 per mg, right? That's a million gallons. If you have that much capacity treatment plant, approximately, this is the biosolids produced, right? You should have some number, how much. So that will help you to understand how you should design the system, what are the various components to be considered in designing this kind of system. I've given an example. A facility treated 5 million gallon per day capacity. It's in the gallons. If you convert that with 3.78, then it will be in MLD, right? So should produce about 640 to 900 ton per year, right? So that is just an approximate number. So 1% of the cultivated farmland could be fertilized, right? So this produced biosolids can be applied to the farmlands, right? There is some national biosolids use and disposal. The one report I have referenced that shows disposal, surface disposal 33%, 45%, and 22%. Is it? I think this number is messed up here somewhere. We'll see, we'll rectify that. The classic and the incineration 15%, surface disposal is 2%, reuse, disposal, and how much comes from the agriculture, reclamation, and forest range land. This is given some number to understand how much is the contribution. There are certain biosolids where if it is a contaminated, what you will do? Then you have to incinerate. That is why yesterday I was telling of wastewater coming from the hospitals, clinics. It has to be incinerated, however small it is, right? Or any clinics, everything should be incinerated. If it is a contaminated, you don't have another way to treat like that. So if that is why how important is to prevent the toxics entering into the systems. This is another number, current quality 2006 biosolids data when compared with the typical soils. This will give you a kind of a understanding. Regulated contaminants. What are the contaminants? We are talking about chromium is also there in that. And mercury is there, nickel, selenium. We were talking about the coal mines there. Selenium is there, chromium is there, leather industries. right? So you know the source from where the contaminant comes into the treatment plant, right? And these are some of the numbers and typical soil concentration and national data on USAP region and particular region. They have given data how much is the contaminants in a 1 kg of biosolids, right? That will give a kind of understanding. Then regulating biosolids in the NPDES permits. NPDES permits in discharging it to the rivers, right? Regulating biosolids, you must have a law first. Then only you can monitor. Otherwise, you cannot monitor. If there is no law, you cannot take any actions on that. So self-implementing, there is in a particular CFR where you can find the related regulation about the biosolids. Must meet the requirement even when not in NPDES permits. Even if it is not in the permit also, you must meet the requirement, right? Permit may contain a state requirement but must be met at minimum of 503. That is the requirements. State level requirements are different, maybe different. Requires reporting regardless if in the permit. You have to report about the biosolids production, whatever the tests conducted on the biosolids. Even it is true for the treatment plants. If they are producing a large quantity of sludge, you can also put the monitoring of the sludge, right? Yesterday we visited a treatment plant. You see, there was a sludge producing. What is said, when it is treated, the solids will come down in the form of sludge. But how we will take care of sludge? For them it may be difficult, because if it is produced in a small quantity, they cannot have a treatment unit for sludge. In a large treatment plants, you might have seen what happens. Wastewater is treated, it enters the different trains of treatment. The sludge from the primary and secondary containment, it goes to the thickener. The purpose of thickener is different from the secondary treatment. There your aim is to remove the sludge, remove the suspended solids. But here your aim is in thickener, your aim is to remove the water, correct? It passes through the thickeners, then you separate the solids and water. That water goes back to the system. It is recycled for the treatment again, and that sludge treated, comes from the thickener, is taken to the drying beds or to the different purposes. Then that can be further developed into a manual, right? So implementation of these permits for the sludge, it is not only important to take care of the wastewater, and the sludge produced from the wastewater is also important. There are regulations for that. If it depends upon the volume, whether you will have to evaluate whether they need an authorization requirement, how to dispose that sludge. If there are many companies which, if they are producing a small sludge, if it is a toxic, there are companies where they can collect from different treatment plants, different industry, and they can build their own treatment plant. Make sure that it is contaminant free. Then it may go to the landfill, and then it is taken care of. There are different regulations. If it is a toxic, hazardous, that is a totally different, comes under different regulations. Then when the sludge is produced, you have to make sure that it is contaminant free. Then you can apply for the soil. There are people, many participants from the soil background. So they must know how important, when a contaminated soil or contaminated water is applied to the land, what consequences it creates, right? So that is why we are taking care of the water also, and you have to take care of the soil also. So both are very important, right? Most of the states have adopted, that is this part specifically deals with the biosolids produced. There are many states which these comes under these regulations. They have applied this kind of regulations to take care of biosolids. Then current federal rules impacting the sewage sludge biosolids, they have given a list of laws, right? How they are developed, they have taken a number of samples, they have put a lot of efforts to develop these regulations, right? You have to have a lot of data to develop, understand what is required, what are the contaminants, is it, how the limits are developed, how the limits are developed. Initially you cannot put the limit. First you should understand each industry, what is the probable amount of the toxicants or the contaminants are produced. Then you can decide how much we can sustain. So that is how the limits are developed. There are many regulations which deals with the municipal solid waste. Landfill requirements are different. We are and also the landfill, 30% of the current biosolid productions. You have seen the landfills. Landfill portion is not covered in this. But you might have seen many of the landfills in the different cities, towns, especially bigger cities. We don't have a perfect plan, but you know, which are those landfills are done long back, but they have enough regulations on that. The the how to take care of the solid waste, how to take care of the landfills. All the landfills are to be must have a secondary containments. Earlier, just they used to dump the solid waste on the ground. That has caused a severe problem. But now, after the regulations in place, they have to be geomembraned. They should collect the leachate. You should have a second, two layers, double layer containers, containments to collect the leachate in the beginning. Leachate production is high in the beginning, and then it will slowly reduce, right? Then one, and there will be a liberation of gases also. If it is if it contains organic compounds, then the gases regulations will be there. After a few years, these landfill will become golf courses. You will be playing on that, right? You have seen many places that way. So those are all, there are regulations to take care of the solids, the wastewater, and also the soil, right? This slide specifically highlights, to make you understand, there are regulations to deal with this also. It is, there are guidance documents, how to develop the limits, how to take care of the contaminants, right? Then methods of biosolids and land applications. You have seen many examples. Their waste, if it is not contaminant, they are used for different purposes, right? And the wastewater is also used for spraying on the large agriculture lands if they are contaminant free, you have seen. And also if it is contaminant free, if it has a lot of soil contained soil in that, then it can be used for road constructions and right, for many other purposes. Generalized area of 503 coverage, general requirements, pollutant limits, management practices, and operation standards, frequency of monitoring, and record keeping and reporting. These are all covered under these regulations. Any solid waste which is generated from the treatment plants, they are covered under this. it should be pollution free, it should be have good management practices, good monitoring system, operation standards, and how much frequency, what should be, how, what is the interval of measurement, and all are important to make a determination it doesn't have any toxicants in that. Land application, metal waste classifications. See, if it has any metals in the solids, you cannot just apply on the lands. Is it? What are the different type of maximum concentrations are given in the table here. You know the list of contaminants. They come from different source of discharge, different industries. Based on that, you have the contaminant concentration, how these contaminant should be taken care before you do the application, right? Yes. Unit? Oh yeah, a milligram per kg is the unit. I think is that missed there? Yeah, that's good. Good. Right. Maximum. I think it has gone milligram per kg, right? It has just merged this one, right? And pathogen destruction is also there. If it has a lot of pathogens in that, if it has a bacterial load, how you will take care of that? One is the contaminants. That is also an important factor in case of biosolids. Another is if it has a lot of pathogens, a lot of people from a biological background, they can understand how much damage they cause. You cannot just put this, biosolids which has pathogens and on the land. That may cause health issues to the public around. This happens with a lot of landfills nowadays. You can see because of limited space, people just stay around the landfills. See how much exposed they are for these contaminants, right? They may be exposed for pathogens. They may be exposed for metals. Also, if it is not well contained, if the landfill is built long back, doesn't have a ways to collect. During a rainy season, you can understand a lot of water percolates through soil your landfill and enters the underground. Through that, it enters the river. How much damage it will cause. See, that is why I was telling often we have a limited space and a lot of people thickly populated. It is very important for all of us to take care of the water and the soil, right? Then you have seen these vectors, attraction, reduction. You see a lot of chemicals are sprayed today because this will give rise to a lot of mosquitoes, vectors, people living around them. There is a complaint, everything, right? That what they do just to keep the public calm, they spray certain chemicals, pesticides on the landfill. But what happens during the rainy season? Slowly it will start again percolate, because if they are carcinogenic in nature, that will enter the groundwater, ultimately to the river, ultimately it comes back to the people, right? So this slide gives a little understanding on the vector attraction reduction. So there are different ways how you can prevent, reduce, but you cannot get rid of it, right? So if they are not maintained, because today there are regulations where you should have a double lined geomembrane, and once it is landfill is filled, then it has to be covered with the geomembrane, then the cover over there, so that it is not exposed for the precipitation and exposed to the people working around, right? That is how it is taken care. But if it is done some long back, 50 years, but still it is there, you should have a ways to clean that. Requirement at the site of land application. The management practices. Agronomic rates, no harm to the endangered species. When you are developing a large landfills, if it is not taken care, then it will affect some species also. It will affect the human beings, right? So no harm to the historic sites. If there is a historic site, if you have a contaminated river, there are examples here, right? You guys know. So if there is a big landfill besides that, what will be the value of that monument which is built, which is our history? Those things are important to be considered in taking care of this landfill. That is why there are requirements today, how the landfills are designed and how far it should be away from the city. But what happens, initially you will design some kind of a landfill in certain area and the city start growing that side. So that is why the proper planning has to be there in order to take care of this landfills and the disposal sites. Groundwater protection is important. Snow covered sites, wet weathers, storage requirements, all these are very important components in the requirement, the site of land application, right? Monitoring and analysis of biosolids, annual production frequency less than metric ton per year, once per year. So you need some kind of an frequency to measure, monitor stability of that landfill, is it? So one per quarter, once per 2 months, biosolids monthly prior to removal. You should have a kind of understanding about the landfill. What is the effects of this landfills to the surroundings? What it consists of? What is happening? How the groundwater is affecting? If a landfill is there, what they will do? How we will measure whether it is discharging any contaminants to the groundwater? You should have a groundwater monitoring well all around. You will start measuring what is the concentration of these metals, contaminants in the groundwater. If it is a nearby river, you will also do a measurements, whether you want to understand the discharge from any water percolates through the landfill and entering into the river. You need a measurement. Once you do a measurement, monitoring, then only you will understand what is happening, right? If you are not measuring, no measurement, no pollution, right? Everything is fine. So that is why it is important to measure the contaminant concentration. What is that? Data is important. Data will speak for that. If you say that it is causing contaminants, if I say it is not causing contaminants, the owner will say, or the person who is responsible. That is why you need a data analysis to understand what is happening. Then you can find a solution. So that is what these analysis are important, to make a determination and to make a planning on that, right? Then record keeping. On or before this particular year, you should have a report, and authorized state programs report as requested by the state has an authority how you will develop, what they should do, whether their side slope are stable, whether how much contaminant are entering into groundwater, how much contaminant are entering into the river? Who will make the decision? You need a thorough study, thorough understanding. Group of people, there may be a third party, many people appoint a third party, expert people to make sure that you have a proper report to make a determination. So that is all comes under this reporting system, and you should have a proper record, because these landfills last for many years, decades. Certain people will get retired. Then how we will come to know? One person, if he has worked for 20 years and another person, how we will understand? You need a proper understanding and record keeping. That means what you are doing, you are creating a system. Whether a person is there or not, the next person can start understanding what has happened, what should be he can take over from there. So that is why this reporting, record keeping is very important, so that the next generation, next group of people can take over the system. Application loading rate, you will understand amount of biosolids produced. What are the components here? Concentration of the pollutants, pathogen treatment, methodologies used during the year, and the results. You should know vector attraction reduction methodologies used during the year and the results. You know, you apply this, what is the effect? How we will understand whether how much is effective and how much is not effective? How we will come to know? You need a number, right? Otherwise, you will not understand. That is why it is very important to do the analysis. Data are important so that you can make a determination, right? So that is all is covered, and how much is useful and how much is not useful. If you are applying a fertilizer to the crops, right, how much crop intake is there, you should know. How much is draining out. There are a lot of people with soil background, they do study. You should what you will do, you will try to understand how much is entering into the soil through that, and then entering into the water, rivers. Is the fertilizer what is applied is completely taken away by the crops? Rest, how we will measure? So those numbers are important to make a determination the effective treatment given for this kind of activities. Standard conditions and bypassing. International diversion waste streams from any portion of the treatment facility. Bypass not exceeds the limitation allowed without notification. Bypass prohibited, otherwise except. A bypass was unavoidable to prevent loss of life, personal injuries. There were no feasible alternatives for this bypass. When you do, facility gives the notice before bypass or within 24 or unexpected. These are the regulations how you should manage these kind of landfills. Right? Then exceptional incident that causes unintentional temporary non-compliance with technology-based employment limitations. A demonstrated upset constitutes affirmative defense to an action brought for non-compliance with such a technology-based limits. There may be a technology-based limit, there may be a case by case studies, each are different. Based on that, you have to make a determination what kind of planning has to be done in order to take care of the waste produced from these biosolids, right, and landfills. Right. So in this lecture, basically we study the biosolids, we dispose it off up to the landfills. If it is good, what you will do? You will use as a manure, correct? I'm just trying to summarize how these biosolids are covered. So far you have studied different regulation system, how the wastewater produced from the industry entering into the sewer system, entering into the treatment plant, and then it is taken care of. You want to make it contaminant free, then discharge, depending upon where you are discharging, whether you are discharging it to the river or applying it to the land, correct? But biosolid is also a component of the treatment plant, right? You should have regulations for that also. Big treatment plant, they can make a good economic decisions on that. They can use this as a manure production. That is why it has to be contaminated. If it is contaminated, what you will do? You need a space to dispose it of. You cannot just go and dump anywhere, even for a road construction or anything, because you know it is contaminated. Because you have measured. If you are not measured, you can do anything, right? Measurement. If no measurement, no pollution, right? If you have measured, then you need a place for the safe disposal. That is why we send it to the landfills. Then there are regulations for that. How you should take care of biosolids, when to use, when not to use, what is the frequency, approximate biosolids produced, and what are the contaminants, how the metals are taken care of. There are guidelines. You need a guidelines how to take care of that, right? What are the technologies, how the landfills are taken care of that. What are the side effects they will cause, whether the waste, because you know when the landfills are just open, imagine a big rain. Somebody was asking a question yourself, right? If there was a rain entering into the clarifier or in a equalization tank, what will happen? There is a dilution, right? Nothing will happen. Dilution we can't do that. When the contaminant is there, if it is your regulation, if says that BOD is 30, if your BOD is 60, you cannot add a water and make it 30 and discharge. No, dilution is not the solution. It is not allowed. You can make it because you need water, right? Good water you are adding. Water scarcity, you know, in many countries, everybody knows in the cities what is the situation of water. We all depend on this, right? So this is the situation. That is why there are regulations. When you create any landfill, there must be a procedure how to manage them, how to measure contaminants, what must be the frequency, what are effects, number of effects. Groundwater is affected. It may enter river, creeks, and people nearby vicinity, they are all affected. Maybe a half kilometer away, still you are affected. A lot of mosquitoes. Somebody was asking about mosquito question, right? So if you are close area vicinity, there is a landfill, because in the initially you will plan landfill should be away from the place, but after some years landfill will come at the center. So then how we will get rid of this? You already built, spending millions of dollars the infrastructure around that. That is why people around that, they start spraying and keep it low. When people start crying, then they spray the something to keep it mosquitoes and other vectors down. But that is not the solution. They are also a contaminant. So that is how there is regulations how they are taken care of that. Not only the wastewater and also the solids. You need a kind of a manual guidance, right? So where to dispose in these conditions, what we should, you cannot ask a particular person. That is why the regulations are made in this situation, how this is implemented, correct? So that is what all is explained in this lecture. So by that way you can understand what are the different components of our treatment system, right? Solids, wastewater, regulations, and the other stakeholders who are responsible to run this system. So all has to be educated, work together in order to make it successful, right? Then your system will work. So if you have any question, we can discuss about that. We have 10 minutes.
Hello, sir. I have a query. What are the commercial use of biosolids except manuring?
Commercial use of biosolids is in many places you have seen they will pack and then they dispose it. That is the good use of the biosolids if it is contaminant free. If it is contaminant, if it has a contaminants, then it is goes to the landfill. If see waste, I mean the solids which are coming from the grid chamber, it doesn't have any contaminants or the pathogens. Those kind of solids, we use it for road constructions and filling of low-lying areas and all you can do. But when it enters to, it has an suspended solids and it has an in the way sludge coming from the secondary, they are all has to be treated, right? We have to make sure that it contaminated. That is the only economic value for the biosolids at the current. Right?
Sir, is there any cases of utilizing biosolids for landfill soil cover?
Landfill, what is that?
Soil cover, covering the landfill.
Soil cover. Soil cover. No, if it is a biosolids, good biosolids, it can be used for used as a manure for growing crops. If it is a contaminant, you can still you cannot use. Just you will dispose it. Right? In the landfill cover, we use a clay soil which is less percolating. Then it is covered by geomembrane and we put a clay soil so that the precipitation doesn't enter the system. Right? You want to seal that and then you can declare this landfill is done, ready for other stuff. Right? That is how it is.
Thank you.
So my question is, as the population of India is increasing day by day, and due to industrialization, deforestation is occurring, and agriculture is decreasing for the land. So is land filling a good way for if for deposition of the biosolid, because we don't have extra land because of increasing population and industrialization.
Correct. That's why I never say that biosolids should be sent to the landfill. Biosolids can be used as a manure. You can apply it to the land for growing crops. If it is a contaminant, then you cannot apply it to the land.
Yes.
So that is only those things you need a space to dispose it off to the land, right?
Thank you.
It is little bit safe.
Thank you, sir.
Right?
Any method for the purification of the biosolids? Even contaminated biosolid used for the landfill, it's also effect on the groundwater.
Yeah, there are methods. What you can do is they clean that water with the contaminants and they make it, the contaminants are carried out by the water and that water is recirculated in the wastewater treatment plant and we'll try to treat and make it clean.
Okay.
That is.
So I wanted to ask that, is there a difference between burning and incineration? And is incineration a sustainable method of management of biosolid or any kind of waste?
If you see, that's a good question. Incineration we use when it is the highly contaminant solids, right? For example, the waste coming from the clinics, hospitals, they are contaminants. It has a lot of contaminants. You can just expose to the outside. That's why we use the incineration. Incineration is the last alternative, you can say. So if it is has highly contaminants in there, contaminated, then you will use incineration. That is the expensive method of treatment actually, but there is no other alternative, right?
Sir, the moisture content, how the atmosphere is created in that unit so that the moisture content is
There are
managed in certain way, because they, however far we go in management, but there will be some amount of moisture that will be still there in solid way. That is my
where
assumption.
once you do incineration,
No, sir. But how is the unit created that the waste which also has moisture is burned in that unit?
you can burn anything. If you take it to 500 degrees centigrade, it will just burn everything.
So even if the quantity is humongous,
That is
case
why
of-
we try to remove as much as possible the water content. That is why the very purpose of thickener I mentioned is to remove water from the solid. Is it? We want to remove water from the solid, then it is recycled for the treatment plant, and the solid is then taken off. Even if we are using it as a manure, we remove water content in that. We want to make it dry as possible. You cannot make it 100%. That is why one of the earlier method was to use drying beds. If the temperature is high in certain areas, they used to make a drying bed, keep it for many months until the substantial moisture content is removed, and then once it becomes dry, they can use it as a manure. That is how they used to.
Thank you, sir.
Hello, sir. I had a query like that. Yesterday, you told in the subject that in your lecture that we are using the water haulers to carry water haulers to carry the sewage water from the small cottage industries to the treatment plant. They are collected from there. If we build the treatment plant in the cottage industry or the plant which is in separate area, like distance from the cities, and treat the water at there and use the treated water in the flushes, like most of the water is used in the flushes in our bathrooms, and the biosolids in the in growing the crops. Then, sir, how would be it if we propose a memo to the government, or if the government provide the subsidy to make the power plants in the small cottage industries or the institutions that working on there, and no water haulers or water transport to the treatment plants? Like we are creating a solution inside the institution or the cottage industry.
I did not understand the question. Can you shorten this?
Yes, sir. Like making the treatment plant inside the industry and using the water itself, so that water shortage will be,
Yes, well, I
and
understand.
also the biosolids used in farming, sir.
Okay, sure. Many industries today, there is an very economic value that it has. They want to treat the wastewater and recycle, right? Recycle and make use of it fully. There are many industries. That is why water reclamation, right? In industry also they do. There is, I remember one Microsoft company that they use a reverse osmosis process to treat the wastewater which is produced and recycle 100% loop, complete loop. They use it as much as possible, so there is no discharge. That is possible. You have a system. That is what the reuse recycle. That is one of the important aspect. We have one example like that. I will take it. So where this water is treated and reused, and even we have done in many industries, they treat the water, treat the wastewater, then we use that treated water for application or to the land for growing crops. There are many examples. I'm also going to take that. You can also, anybody in the tutorial, you have opportunity to share your thoughts, share any example also. We can have a kind of an interaction on that. There are many examples today. That is the one of the prominent development in the wastewater world. We want to use recycle, reclaim, and reuse the water. So that is happening already.
I want, sir, that like the government also support the peoples, like providing some subsidy to the industry or the small industries to make the self-treatment plant.
I think there may be, I don't know the subsidy here, but there are maybe some you can say some benefits from the government also if they are using it. It is quite and industry itself saves a lot of money. Taking water from the sources itself costs too much money, right? Right. We will take some tutorials. I will tell you how successfully it has been done in a very large scale. Right. Okay.
Thank you, sir.
Hello, sir. These biosolids can also be used as a sludge briquettes, so that it can be used in blast furnace as a sustainable fuel source in place of burning coal and all. And two advantages will be in place of dumping in landfill, it can be turning into briquettes, and one more thing will be uh, exploitation of coal.
Uh, it depends what is
Yeah, what
the
kind of
thermal
biosolid it
value,
is.
thermal value of the
Yeah.
coal, right? Thermal value of the coal. I think you guys have what? She can answer that question very well. She has worked on it.
Actually, right now research is going on in the direction of the blending of solid fuel with the coal fines. Not exactly just the briquettes of the solid fuel, purely solid fuels, but we can do the blending, sir.
Blend.
Blends of some portion of the biosolid plus with coal so that its thermal value can be maintained
Yes,
and
exactly.
it can use. And so one more thing is that rather than just go for the solid fuel, right now research is also going in the direction of green hydrogen production by using of that biosolids.
Very good.
That is in a very nascent phase, but still we are in a few places this work is also going for the green hydrogen production by using the biosolids.
Correct. So thermal value is important. What purpose you are using? How much blending has to be done like that, right? So the another example is for organic waste. We do an anaerobic treatment and methane is produced, but methane is doesn't have that much thermal capacity. That's why we blend that and make it sure that it has a proper thermal value so that it can be used as for a cooking gas or as an fuel, right? That is all.
Hello, sir. You mentioned a slide in which you share the data of US that this amount of daily biosolid they produce, but in India this value is not identified. How we quantify this value?
Okay. That is why you have to generate. You have a system in place to do that. You can adopt the same model here. You need all resources, people to take care of the wastewater produced, biosolids produced. Then only you can make a determination. That is in a very initial conditions. Then step by step. I think all of us should work together to move it forward.
You also mentioned that this amount of arsenic is present in biosolid of USA.
How that is generated? Because they have a measuring system.
Yes, sir.
They measure everything has to be reported. If that goes into a database system, that is why we are able to find out how much is the contaminant in this. But if you don't measure, no pollution.
So if we measure that the same amount of arsenic value is found in India.
No, it may be different, but I am telling you, you can keep a track. Then you can make a determination, right? Once, if you do not know how much is the produce, how much is the contaminant present, how you can make a solution for that. That is why those data are important. If I say, I was giving an example, if a big landfill is there, Yeah, there are no, there's a besides it goes to the, it may contaminate the groundwater, it may be the river. If you measure, then you will understand what are the contaminants, right? That is why the measurement and proper plan, procedure, regulations, and all they are important in order to understand what is the contamination level. That is a very important aspect of that, right?
Sir, I have one more question. And how safe it is to use that treated industrial wastewater, that too for this farming? Because we know about this trophic level and pollutants, that is bioaccumulation and biomagnification, and some of the heavy metals, trace metals will be there in food, and that too in metropolitan cities.
The wastewater which has any metals, it cannot be applied to the land. First, number one,
Okay.
right? If you are not taken care of the wastewater properly, ultimately it will end up in soil or in the river, and it contaminates the water.
Exactly, but not every industry will be having a tagline like ZLD, zero liquid discharge industries, and some industries will be discharging, and finally it ends up in water sources, and it contaminate, and it will be entering this food chain.
Definitely it will go into the food chain, because if there are some pollutants which are carcinogenic in nature, if you are not taken care of them, it will end up in the soil or in the water, and ultimately it enters the food chain.
Yeah.
People eat fish, it may enter the fish,
Yeah, that is
right?
biomagnification.
Yeah, that is possible. That is what is happening. So that is why it is very important for us to take care of the wastewater, right? Contaminated water, contaminant have to be removed and then discharged.
How to make sure that the water is safe for agricultural activities?
No, you can do a measurements. Wastewater before applying to the land, you have to make sure that this water can be applied to the land. It is not drinking. Not only the drinking water is measured. It is also when you are applying it to the land, you should make sure that it is contaminant free.
So
If it has for example, nitrate is there, then some portion of the nitrate is taken by the crops, and some portion is remaining. You have to make sure that this is not causing any pollutants to the either to the groundwater. That is why we make sure that how much is the crop uptake and how much is entering the groundwater. The component which is entering the groundwater is not causing any groundwater pollution. That is why the measurements are important for that. And you will also monitor whenever you are applying the wastewater to the land, you will measure the you will take the soil samples, and measure how much is entering into the soil.
But I don't think this is happening in India, right?
It will happen.
Just I will interfere here.
Yeah.
Yeah. At Panchanagar also, we have some research projects which are going on at Environmental Science Department. I think the students can highlight that thing. Okay. There, that whatever that domestic wastewater I am talking about from our colony called Ta colony, if I am right, entire that will be collected and that will be passed through a canal. Okay, means constructed thing, and then they will put up a series of natural trees which can treat that wastewater. It's a natural treatment, no pumping, no nothing is there. It is just due to gravity only. Sometimes we are taking serpentine such that residence time will be more, so that all those particles, so they will be absorbed in that land, and that land also, yeah, some of the domestic wastewater is fertile. You can I think if time permits, we will take you over there also. It is just a walking distance from here, because there is a smashan is there. Okay, smashan means a crematorium. Okay, so near that we can just observe how that quality of wastewater differs, and also how the trees growth is also different. Some of them they are 5 years old, still you can observe over there the difference and other things. Yeah, they are testing. It's a part of our, I think, DST project, and also some It's an international project with Netherlands. They are working. Whatever you said, yeah, they are testing the inflow, they are testing the outflow, and then that water will be released to the river or stream, I should say, of our Pantanagar. I think Beni River. Huh? 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 The river they will discharge it. So they will test it and then only they will put it. And that water is used for agriculture purpose also. Agriculture means, like as I said, you can see those trees. You can observe the difference based on nutrients. It's a domestic wastewater only. Okay, from our colony. Sorry.
Thank you.
Yeah, it was enough. I think we should stop. And stop. One of our Doordarshan Uttarakhand.